Okay, so here is another question that involves differentials, focusing around really Newton's second law again. This is from the 2013 exam, in the free response section. So here's what we have. We've got a box of mass m initially at rest acted upon by a constant applied force of magnitude Fa. As shown in the figure above, the friction between the box and the horizontal surface can be assumed to be negligible, but the box is subject to a drag force of magnitude kV, where v is the speed of the box and k is a positive constant. Express all of your answers in terms of the given quantities and fundamental constants as appropriate. Okay, so again, this is just an algebraic expression. Typical part A, the dot below represents the box. Draw and label all the forces, not the component. Okay. Remember that not the components part is very important, because especially if it was at an angle, right? You don't want to do the x and the y's on there, because this is really the only time that College Board will take points off of your free response section. Okay, so let's draw the forces. Excuse me. All right, we have our two standard forces, the normal force up, the weight down, right? Typical of something on a surface. We have this applied force that they call Fa, and then we have our drag force, right, of which they tell us is equal to kV, right? But we'll just call it F drag on our scoring free body diagram, right? And so now we're going to answer the rest of the questions. Part B, write but do not solve the differential. So remember, in part B, the important thing here is we're just going to write it, but we're not going to solve it, right? We're going to solve it actually in part D, okay? So we solve the forces because friction is negligible. We don't have to worry about the y direction. So we just have the applied force minus the drag force equals m times a. Okay, so they tell us what FD is, and we can figure out, remember our differential is going to be contained here in the acceleration. So we're going to have Fa minus kV equal to m dv dt, right? That is a differential because remember this right here signifies the differential piece. Okay, that dv dt is our differential. You can also, if you want, kind of divide everything by m. So Fa minus kV divided by m. That is another version. And then it would, again, you don't have to do these last two, but it also could be beneficial to give each piece the m. Okay, when solving. But really, you can, this is the differential that they're going to look for. Okay, so really it's probably a point for this and then a point for that. Okay, and then the solving comes later in part D. Okay, now let's go over here to part C, which again, very typical of this style of question. It's going to ask you for the terminal velocity, so it's going to determine the magnitude of the terminal velocity of the box. Even though it doesn't sound like it, that this would have a terminal velocity, it does. Okay, so we left it off at here, right, with our differential. But remember, terminal velocity is when this term equals 0. Right, so really we just have Fa minus kV equals 0, and at this point we can put a little sub t there, so that we can just solve for Vt. So we're going to subtract over Fa and divide by k. All right, so there is our terminal velocity. Okay, and the way they break it down, this was a 1-point question or 1-point part, so you got 1 point for finding the terminal velocity. And the part B, I'm looking at the scoring guideline as I'm doing this. Part B does give you 1 point for finding that FG minus F minus KV equals MA, and then another point for actually writing that differential. Okay. All right, now the next part, part D, now we're going to solve that differential from part B, and they're going to give us these initial conditions, which we need. Okay, so we need to write, here's that differential where we left off. They say right here at V equals 0, or V equals 0 at T equals 0, so it's like saying V of 0 equals 0, okay? Remember, we're going to have that plus C aspect. So we're going to have to figure out what is C equal, and this is, right, they give us the initial condition, and that's how we find it. All right, so now we're just going to remember the process, separate the variables. Get anything with a V to one side, anything that does not have a V to the other side. So what I'm really going to do here, I'm going to multiply by dt over m, right, first. So I'll have dt do 1 over m times dt times this FA minus KV equals PV. Okay? The next step would be to divide by FA minus KV. And now we'll get to that point where we can then solve it. Okay, so we have 1 over m dt left on the left side. And on the right side, we're going to have this 1 over FA minus KV BV on the right-hand side. Okay, so now we have our differential separated. We have our variable separated. Here's now where we take the integral of both sides. Right? I can make that different color. So I thought I'd selected the black pen. Okay. And because 1 over m is just a constant, I'm going to leave it outside. Okay, that's why I did that. That's why I didn't bring it in with it, because that is just a constant value. What we do have to do, right, for the 1 over FA minus KV is we have to do our, we have to do U substitution. So remember, we're going to say U equals FA minus KV. And then we're going to find du dv, right? So we're going to take the derivative of that, and that's just going to be negative k. And we're going to solve it for du, and then negative k dv. And what, remember, u substitution looks for what is left, right? So we have to get dv from what we have here, right? So there it is right there. So all we have to do now is just divide by k, or excuse me, negative k. So we get dv equals negative 1 over k du. So if you actually look at the formula sheet, it's going to tell you 1 over, I think it's something like, let's just say a plus bx, right, or something like that. Taking the derivative of this, the answer is going to be the natural log, right, 1 over b natural log of a plus bx. Okay, that's what, in this u substitution process is where that comes from. Okay, so now I'm going to rewrite my function. Let me use a different colored pen so we don't have like everything kind of crowded in red and black. Although there's a great calculus help video or help on YouTube. His name is Red Pen Black Pen, because that's what he does. He alternates between a red pen and a black pen. So what's left, I have 1 over m integral dt equals negative 1 over k, the integral of 1 over u du. Okay? So when I integrate this side, I get t over m plus c, right, equals negative 1 over k natural log of u, right? And now we're just going to go about solving, right? So now I'm going to multiply by negative k times negative k. So I get negative kt over m. Oops. It's a weird, starting to look like a weird m. So plus c, right, equals ln of u. Okay, and now I go to get rid of the ln, I go e to the both sides, I raise, and then so that just becomes, let me give myself a little bit more space here, right? And so this just becomes c, right? So e to the c is just simply a big C, e to negative kt over m equals u. Again, we know what u is, right? So we're going to plug that, now we're going to substitute that back in. So we're going to ce, and the app decided to change it to a circle. It was FA minus KV, okay? And what we need to do here is figure out what C is, right? Where it tells us when t equals 0, V equals 0, right? And so it's going to be C e to the negative k times 0 divided by m equals FA minus k times 0, right? And so this whole thing over here is 1. So this is going to equal 1, right? So basically, kind of weird how I wrote that. So on the left-hand side, we're just going to let C left over, and on the right-hand side, we're going to have FA, okay? And so now we just plug all that in together and then solve for V. And so we're going to say FA, because now I'm going to plug in my C, equals negative KT divided by M equals FA minus KV, right? And so I'm going to subtract FA over. So I get FA KT e to the negative KT over M minus FA equals negative KV, right? And then I'm going to divide everything by negative K, or I can say negative 1 over K. In fact, we can make it look like we did in the skier question, right? So if I pull out an FA, I get e to the negative KT over M minus 1 equals negative KV. And so now I divide everything by negative K, so that becomes so it goes FA over K times 1 minus e to the negative KT over M, and that will equal our V. Okay, and so here is the velocity, right, in terms of time, right? So as a function worth of time. And then what you actually see here, here's our terminal velocity function, right? Our answer to part C. Okay, so there's just another example of using differentials in physics. Okay, I'll keep looking for more examples, kind of scour through the kind of question bank that I can find for free response questions, in particular using differentials.